Hello, my name is Artur and I'm technical artist at Redhill Games. I joined game development in 2012 as a 3D model artist, and I was making props and assets for games. And in this process I found that between the creation of the asset and actual seeing it in game, there's lots of routine tasks that I could make easier and smoother. And I used scripts and I used specific tools that are making the process non-destructive, and one of these tools is Houdini, and I will talk about it next.
SideFX Houdini is a very versatile tool. You can make almost everything for game with it, and the only limit is your imagination. Houdini engine is very good for either complex stuff that is not easy to make for 3D artists, or for very simple but repetitive routine stuff. I'll show some examples of simple tools, and after that there will be a detailed overview of a more complex tool. Here are examples of simple tools. Borders and road generator use input spline and drops generated mesh to the terrain. Cables tool use the input spline and generate tube-like mesh with UVs and collisions. Tool has a slot for custom end meshes, and 3D artist can attach his own ending for the cables. Cloth drape tool takes the selected meshes as collision inputs, and we can drop a rectangular cloth drape on top of it. It uses vellum cloth simulation and gives out clean and optimized mesh with optimized collisions and specifically made UVs. This tool used to create all these tarps right in place in the editor. Let's move on to a more complex tool. It is a water surface generator. As a technical artist, I've got a task to make realistic waves for the lake's bay water. Main goals were to make realistic waves that would go up into the lake shore and flow back. The waves should be 3D and should not fade and stop at shoreline, so player doesn't see a constant flat line where the water plane intersects with the terrain. Water surface should blend smoothly with the terrain and other water outside the bay. Waves should have moving form. Ripples should bend and distort in respect with every mesh object that has contact with the water. I knew that the shoreline of the bay could change at some point. Also, we don't have a distance field data in our project, so flat water surface wouldn't really fit the needs. And I can't rely on the water shader and screen space data, so it has to be done another way. Solution for that would be a tool, so we could generate the water surface in the editor, bake all the needed data to it, and use it in the shader. And we can update it, rebake it, all the data, if the terrain is changed. To make wave realistic, they definitely should be 3D waves. But the problem with the 3D waves is that they either fade out completely on the intersection line of the water surface and terrain, or they can be cut by terrain, and those separate waves look strange. To avoid that, I decided to make water surface overlap with the shoreline terrain and conform to it, so waves doesn't stop but could go up a bit, stretch, lose energy and fade more naturally. That helps to get rid of separate waves and to create a wet sand area. Wave height is defined by maximum between the wave height and terrain position Z, plus little bit of offset to avoid Z fighting. I needed some data from terrain and everything that touches the water, like big rocks and obstacles. I stored that data in 3 vertex color channels and 3 UV channels of the mesh. So the red channel contains a mask to blend with the flat water outside the bay. Green channel has the inverted distance to the terrain and obstacles. Blue channel has the normalized water height after it was projected to the terrain. It is normalized to the range of 0 to 1. UV channel 0 is terrain slope mask. UV channel 1 is flat UV for texture. UV channel 2 is the flow map. Here we see the Houdini node graph. Node graph is not very big, and it has 4 input nodes, 2 splines which define the water surface borders, 1 world outliner input for obstacles, 1 input for terrain. Here is what obstacles and rocks are. Terrain input from Unreal, converted to mesh and its borders are extended. 2 input splines make water surface bounds. Water surface bounds are extruded. Terrain is cut out with Boolean operation. Obstacles and shore above the water combined to flat solid mask. And this obstacles mask is extruded to use it later. Surface cleaned and cut out with slope angle threshold. I created a subsolver that is used to make directions for the flow map. This subsolver creates the direction lines that go from one input spline to another, and these lines are searching the area around it and try to avoid the obstacles. Also, these direction lines are bent towards the shore to make believable flow of the waves. Flow map is calculated based on these curves from subsolver, and then it's blurred and stored in the UV channel. The water surface is flattened to the specified height, but the overlapping part of the water that goes on to the shore keeps its height. Mask, distance and height is calculated and stored into the vertex color channels. Terrain slope is calculated and stored to second UV channel. Mesh is optimized with the poly reduced node to remove the unneeded vertices and keep the density low. Unreal specific parameters are set and mesh is passed to Unreal. I used 6 textures for the shader. 2 of them, the waves textures I made, and other were already in the project. At first I made only 1 wave in the texture, but that looked very repetitive. And to break that I added another wave with a different shape and offset on X. That solved it. Other textures I used were small texture with a purling noise. It's a very handy one, I reused it multiple times in the shader. 2 ripple normals. One is very small and turbulent. Second one is bigger, directed ripples. And packed foam texture, each RGB channel of which contains tiled grayscale foam mask. Here is the quick overview of the baking on the wave textures. First I created a wave from curve and extruded it. Made its height fade smoothly on both sides. Made a copy and bent it a little bit. And placed them both over a square grid. Duplicated the whole graph for green and blue channels. I needed the waves with a different length, so I baked 3 color channels separately. And I baked the normal map with the Maps Baker tool and recombined channels to a texture in the COP network. Now let's see what is inside the water shader. Here you see the shader graph overview. I like the straight line, so it makes it more readable. The material is translucent, shading model is default lead, and it has 906 instructions. So here we have the wind angle mask. If I change the wind angle, the baked slope mask from UV channel 0 is used to calculate areas around the shore and island from the side of wind direction. This mask is used to limit the waves and foam based on wind direction. And this is a forward wave. UV coordinates is a masked mix of flow map, regular texture coordinates rotated to the wind direction, and shore mask. Wind angle affects wave direction, and also waves are bent with the flow map. Here I have parametric control over the waves scale along X and Y of the texture. So we can make waves shorter or longer, narrower or wider. Forward wave has to decelerate when it lost its energy, so I used this function to control it. The function gives S-shaped curve, and deceleration can be controlled more precisely compared to simple power function. Reverse wave has the same UV coordinates as the forward wave, but they are inverted, so wave goes in reverse direction. It also have additional offset in UV space. As reverse wave goes down and accelerates, simple power function is used and gives good results for that. Reverse wave reuse the same texture, but this texture is rotated 180 degrees. And this parameter controls how strong reverse wave is and how fast it fades away. Next group is normals. Waves, normals, textures are moving using the corresponding UVs described earlier, and I blend it with additional turbulent ripples normals, so reflection would look more chaotic and realistically distorted. And this turbulent ripple is limited with the shore mask from the green vertex color, so we only see them where the waves appear. Watercolor was made by Eero Hara, our art lead, and I based my shader on it. It is buffer-based color that uses scene color and distorts it with normals, and color has nice realistic gradient based on the depth, and it all goes to material as emissive. Now, here we see the form groups. Form distortion noise, which is added to moving form to distort it. Static form, which is always there and pushed slowly towards the shore. And 3 form texture channels split to move with the waves in a different manner and break the similarity. Also, there is specific additional noise that breaks repetitiveness of the form even more. For distortion, I use panning noise texture that is fed to form texture UV. Static form used the same packed form texture. Anti-tiling mask used noise texture 2 times with different scale and speed and multiplied by form color. For the moving waves form, I used 3 channels of packet texture and added together with various scale and move speed. Waves made 3D with the world displacement option, and it uses tessellation. Here I have wave height and ripple height parameters. That sets the maximum height of the wave and ripples, and I use combined forward and reverse wave texture and channel B of ripples normal texture, increasing the waves and ripple value makes them really noticeable. Though, high values make vertical stretching of the foam texture visible. I have to say that this water tool is very specific and is used mainly for the environment purpose. Water is static and doesn't give any feedback to gameplay actors. Additional VFX should be added so it responds to bullets and grenades thrown to the water. This is it. I hope I didn't bore you with the technical details that much. Thank you for watching and I'll be glad to answer your questions.